Thank you very much, folks, for your company. Welcome back to your channel, Transmission Lines Engineering TV. Well, after several previous videos dealing with historical and administrative topics, we have finally come out to the technical topics. We will now see many electromechanical topics now. I mentioned electromechanical because it is my area of expertise, since I'm not civil for foundations, but at the same time I see this channel as an opportunity for myself to start researching and studying civil engineering for foundations, and later develop more videos including design for foundations in transmission lines. So without further comments, let's get started. The alignment of a transmission line has several components. As number one, we have the authorizations with the multiple owners with whom you will have to negotiate, since each owner is different and with different requirements and very varied. This work, I have to tell you, is not an easy task. As the second component, we have the authorizations with third-party agencies to obtain the permits, such as crossings with roads, railways, rivers, airports, protected ecological zones, archaeological zones, etc. As number three, we have the calculation of the right-of-way, which is not always uniform throughout the line, and there might be sections where it is narrower or wider, depending on the negotiations that are held with the owners to achieve the crossing authorizations. On the other hand, the mathematical calculations of the width of the right-of-way, that's something that will depend directly on the height of the structure, the sag of the conductors, but above all, the effect of the wind on the cables. As a fourth component, we have not only is the right-of-way what should be calculated, but also the temporary working areas or temporary working spaces for the positioning of the assembly materials for the structures on the ground and placement of the cable and stringing equipment, since they are not located right next to the structure but several meters away from the structure, so that the vertical tension component is as small as possible, and neither the tension in equipment nor the cable and the structure becomes damaged. So, having these four basic concepts already known and understood, we will proceed now to see them in more detail. In the case of the calculation of the right-of-way, that's something that we will leave it for the next video. So we have the first one, authorizations with owners. After the moment of requiring a new transmission line, the client or future owner of the transmission line must make multiple visits to the site, initially by air, to identify those areas which present fewer obstacles for the access roads, easy handling of materials, location of structures, and to avoid to interfere with private properties. Unfortunately, every line always requires negotiations with landowners, so it is necessary to have drawing detailing the positioning of the structures within each property with the dimensions of the areas to be affected. A particular visit to each owner is necessary to obtain his or her authorization. In fact, the companies which own transmission lines sometimes organize public conferences called open houses to quote the multiple owners affected in one single event. In this way, you can identify the owners who have no problem installing the structures on their properties and those who will require more detail. In the case of private or commercial or industrial owners, all the requirements of each one will be met in a book which will be delivered to the design contractor, establishing the criteria of the structure's locations. Many owners have different requirements, such as being contacted before starting any construction work, and there are cases in which not always a design is based on a pre-established specifications or calculations, but it must be resolved with the most valuable thing in a human being: its creativity. Now we have authorizations with agencies. Another type of authorizations, completely different from landowners, are those where the transmission line crosses with third-party public service infrastructures, in which something more than just convincing a person to place a tower in their property is required. A complete package of administrative and technical procedures should be generated, which will include much more detailed drawings requiring the series of calculations that met the established specifications. In previous videos, we have talked about the document called crossing drawing. This is where this document comes up, and hence its importance, because in the design of a crossing, requirements must be met from the owner of the line, who will call him the client, and the owner of the infrastructure that we are crossing with, we'll call the third-party agency. The crossings which require this type of permits are airports, rivers, navigable or not navigable, roads as primary or secondary, railways, pipelines, either be superficial or underground. The process of obtaining the necessary permission from a third-party agency is as follows. Step number 1, identifying the nature of the crossing and the agency to reach. In general, each agency has a section for the review and issuance of permits. The step number 2 is going to prepare the design of the crossing, taking into consideration the vertical clearances from the ground level to the lower cable, which should be in conditions of maximum sag and with plastic deformation, which is grip. Concepts that we will look further ahead in another videos. On the other hand, there are horizontal clearances, because let's remember that these infrastructures to cross, likewise transmission lines, also have their very own right-of-way. So they require certain distance between the limits of the right-of-way to our structure. Additionally, the sag and tension calculations within the crossing section must be done to inform the third-party agency how our cables will be installed and the types of the conductors that are going to be used. Another very important information that will be required by the agency are the foundations to be used in the crossing structures. The information for the foundations are usually only explanatory, since no calculations are required usually. As number 3, we have, once the design is finished, the so-called crossing drawing is developed, which will contain the design in plan and profile views, and in addition, details for the vertical and horizontal sections, as well as the type of the cables and their tensions, and followed by the type of the foundations to be used. This drawing, before being sent to the third-party agency, must be sent to the client who owns the transmission line for its initial review. Once the design has been authorized by the client, the drawing will be reissued with a new revision and stamped approved for construction. This stamped drawing will be sent to the third-party agency together with the administrative documentation for the review and authorization. The third-party agency will issue its approval or comments for its adjustments, and once the drawing is approved, the third-party agency will issue the same drawing with its approved stamp and a letter of crossing authorization together with its conditions. Now, it is very important that during the construction activities there are no major modifications to the design, because if another type of structure, a different foundation, or a different cable is required, the third-party agency must be notified and the process will start over again, with the possible consequences of delaying the construction on this crossing, because this type of authorizations take their process for quite some time, about 2 to 4 months on average. We have now another topic, the calculation of the right-of-way. The topic of the right-of-way width, it's a more complex topic. We will begin with its definition. Well, what's a right-of-way? What is it for? The right-of-way is like the land of our houses. It's a private property, but even though it's ours, we are subject to certain rules of use. That is, we must respect our neighbors. In the case of the transmission line, the right-of-way is a passage, it's a path along the line on which we can patrol the line for its inspection or materials transportations without affecting the owners of the adjacent areas to this right-of-way. And now, accessing to this right-of-way has a study methodology. That is, a detailed analysis must be made of the existing roads which intersect with our right-of-way, but these roads are not always in acceptable conditions enough to support the transit of vehicles transporting heavy construction materials and equipment. So it requires certain adaptations to make them safe, or it might be that they don't exist at all and we have to build them from scratch. So in these cases, it is required to process a permit from the local authorities for its construction. This system is called access roads, which must be part of the alignment package or routing package of a transmission line to give a mapping of how to access the right-of-way from existing roads. On the other hand, the width of this right-of-way has two stages, two phases. Number one, we have the mathematical calculations of the right-of-way. That's something that we will leave for the next video. As number two, we have the width negotiations with landowners, since sometimes they don't always give their authorizations for the width that we have mathematically calculated. It might be that for an owner, his crop is affected, and if he's asked for the full calculated width, maybe he agrees to provide a smaller width, a smaller section. In such a case, smaller structures with shorter spans are necessary so that the horizontal swing of the cables due to the effect of wind are not so pronounced, so big. Now we have the temporary working areas. The right-of-way is one thing, but thinking about the logistics of where to place the cable tension of the equipment and the materials for the assembly of the structure, that's another very different thing. We must think about how to dimension the temporary working spaces. These working zones might exceed the dimensions of the right-of-way. especially in structures where there are deflections in changes of the direction of the line. In the case of suspension structures or tangent structures, these working areas are positioned on one side or the other of the location of the structure. On the other hand, a structure with change of direction or point of deflection called PI is necessary to provide additional space for the assembly of the structure and much more for the location of the tensioning equipment or stringing equipment at a distance far enough from the structure and aligned to the cables to avoid inducing vertical loads to the arms of the structures during the stringing, which might lead to damage of the equipment or the structure and fatal accidents, including human losses. This phase of study, in my very personal opinion, it is very beneficial to invest time in planning the location of the equipment, discuss it with their respective clients, so that during the construction of the line, there are no misunderstandings with the landowners. Finally, the fact of that the owner of the transmission line has obtained the release or permissions of the 100% of the right-of-way along the line, it doesn't mean that it is their property and or has been expropriated from the landowner. The right-of-way is like a kind of a lease contract in which the owner of the property grants access permit to the owner of the line to carry out construction, operation, monitoring, and maintenance activities along the transmission line. Well, I hope this video has been helpful for overview for those points to take into consideration for the definition of your line alignments and know the possible problems to solve during the process. I take as well the opportunity to remind you that online training courses will be available in my website in much more detail for the design of transmission lines. Thank you very much for your kind visit. Don't forget to subscribe and leave me your comments on this one. So until next video, Transmission Lines Engineering TV, training to power the world.